So this is the Vehicles Breakout session, and I'm Dave Debney. I'm the Head of Technology for Whole Aircraft here at the ATI. So, before we start, as was discussed in the main room, we're going to be using Slido for the questions. So if you haven't already logged onto Slido, please do so now. The details are on the screen. Essentially, you can ask questions through Slido and you can vote for questions that you would like to be asked. And quite simply, I'm just going to go down the list of questions with the panelists and take the discussion wherever you guys want it to go. Ultimately, this is about having a bit of an interactive session. This morning we've had some really interesting ideas. Obviously we started out with Gary and others looking at some of the challenges around the wider industry. Simon touched on the technology strategy, and here now we're going to focus in on the vehicles section in particular. So, this is about to go, so if you haven't already signed in, do so now. It's about a 10-second warning before I move to the next slide. Someone's even taking a picture of the Slido details. That's very forward-thinking. Right, so technology priorities. So Simon obviously went through what are the different blocks, if you like, that make up the ATI strategy, and this session is specifically focusing on the sustainable vehicles. So just to remind ourselves, what were the three priorities that we talked about? The first one was retain and grow whole aircraft analysis capability. The second was to be a key player in the delivery of future sustainable commercial aircraft. And the third was to lead the way for sustainable new markets, new vehicles, urban and regional markets. So let's take a moment to consider what each of those actually mean. In terms of the targets and drivers, there are a few different things that we can look at. The first one, the key things that we've come up with are reducing cost, improving energy efficiency, protecting the environment, improving operational needs and flexibility, enhancing the passenger experience. Now, some of you, the sharp-eyed among you, will be wondering why there's a star against reduced cost. That's because to do all of those other things, actually, doing all of those and reducing cost at the same time is going to be really difficult. And actually, maybe we need to, in some cases, accept that we're not going to reduce cost. That's part of the challenge that we need your help to answer. Where can we accommodate additional costs if it ultimately benefits the end users in the UK? And the one in the middle seems obvious, but ultimately underpins everything. Improving safety. Aviation has got to the enviable position that it's in because of its safety record. So for everybody that says, actually, if you're looking at urban air mobility, you can be a technology company, safety's not important, I completely disagree. Not many people know there used to be a helicopter service between JFK and the centre of New York. In the 60s, they flew Chinooks, or a version of that aircraft. What killed it was a fairly small number of accidents, and we need to be really careful that we don't push the urban air mobility in the same direction. So, let's look at the first of those, retaining and growing whole aircraft analysis capability. There are a few examples up on the screen here. The first one on the left is the Boeing CRM, the Common Reference Model in the wind tunnel at Farnborough. Most people in this room may or may not appreciate that basically every Boeing aircraft since the 80s has been tested in the kinetic wind tunnel at Farnborough for low-speed regime. That's a really, really proud and enduring legacy for the UK, with a non-UK company using UK capability and relying on it. Whole aircraft capability, the next one, is a model that we've put together. Simon talked about our whole aircraft capability that we're quite proud of. One of the things that we're looking at doing is asking ourselves, what will an evolutionary aircraft look like in 2035? People talk about hybrid, people talk about new technology. All of these things are great. But people also say, well, it needs to be better than an A320neo. Well, actually, no, it doesn't. It needs to be better than what conventional technology can achieve in the same time frame. And that's actually going to be quite a difficult challenge because things are proceeding apace to develop new technologies in a range of areas. Aerodynamics is a key one. Again, the UK is strong in this capability. but in particular, the complexities around engine, wing, nacelle integration, all of these things we can need to look at improved models to really understand where things are moving forward. And things like tilt rotors on the right-hand side. We've got a number of projects that are already related to this. High-value design, or the Brunel Challenge, is a really good example of where we pull these capabilities together to look at what do things mean at top level in terms of the aircraft. If I have a system, an avionics system that's 10% lighter, so what? What does that actually mean? And that's one challenge I'd like to throw out to everybody in the audience today. One of the challenges I've asked within the ATI is, how can we leverage our whole aircraft analysis capability to help UK industry? I've got my ideas, but actually what I really want is ideas from you guys. What do you need? What do you need from the ATI? If you're a systems company, do you need help in how you go and pitch to Boeing and Airbus and Bombardier and the other airframers as to what your idea actually means? If you're a technology startup, do you need to look at how your modelling can interact with other parts of the system? It's an open question. I'm here until, for both days of the conference, and I'm here on the TAGSAG day. If you've got ideas, come and find me, or please come and find a member of the ATI and instigate that contact. Because ultimately, as Simon said earlier, we're here to help you. That's part of the mission that we're here to do, is help you guys leverage our capability to further your business opportunities. So moving on to the next one. The future sustainable commercial aircraft. As Simon touched on earlier, this ultimately is where the really significant sustainable challenge in the near term exists in the industry. If you take the UK for an example, 95% of all UK aviation emissions are international, not domestic. The UK is fairly unique in that regard. The US and China have fairly different markets. But we need to make sure that we're taking that into account. That means that, aircraft the size of the C-Series, the A320, all of these aircraft are the real emission generators that we need to be attacking in the first instance to make a difference to the UK. Electrification will help, but it's still quite a way away from making a big impact in that space, which is why we think sustainable fuels and air traffic improvements are critical in addition to looking at vehicle improvements. There we go. And then finally, the UK needs to lead the way for sustainable air vehicles in new urban and regional markets. There are just some examples of some of the exciting things we've already got going on in the UK up on the screen. The Islander that you can see there, so we've recently announced Project Fresson with Cranfield Aerospace, Rolls-Royce and others, looking at installing a hybrid propulsion system into an Islander aircraft. Now, the really sharp-eyed among you, I can't quite see it actually, will notice that it's Logan Air branded. So that's the airline that operates in the Scottish Highlands, which includes the world's shortest commercial flight. I think it's about 1.4 kilometres. I mean, quite literally, they get off the ground and cut the engines and glide down again. So actually, in that sense, it's an ideal proving ground for electric technology. We've also got Zero Avia, so that's the one to the right-hand side. So that is a fuel cell program here in the UK, looking at how can we develop hydrogen fuel cells by converting smaller aircraft to prove the technology. Some really interesting ideas coming to the forefront, and the ATI are genuinely active in this space. Some of the others you may well be familiar with. The City Airbus is one of Airbus's projects looking at urban air mobility. We've got the AW609 tilt rotor that Leonardo have been working on. And actually, I would say, is the tilt rotor with a civil tilt rotor that has notable flying experience that not many other companies in the UK can boast of. And then the vertical aerospace Seraph, which will be talked about more in a couple of minutes. So, why are we here? You're not just here to listen to me talk. We have a really interesting panel lined up to answer your questions. So who have we got? We've got Dave Best from Airbus, we've got Martin Ashford from Leonardo, and we've got Michael Cervenka from Vertical Aerospace. So what we're going to do is we're going to hear a short intro from each of these guys, telling you a bit about their company and some of the challenges that they see in the industry. and then we're going to get into your questions. So if you haven't already, please get asking on Slido and please get up voting. Okay, and with that, I'm going to hand over to Dave Betts.
I mean, Dave talked a lot about challenges. My main challenge was trying to find a picture that hasn't been seen this morning. So there's one there. So Grazia mentioned earlier, and we're looking at our 50th year of Airbus, and we're a commercial aviation company that's probably most renowned for its aircraft, so the A380, A350, and the single-aisle A320 size aircraft. Historically, we've been mostly a European sort of based organisation. Is there anyone from Boeing in? No, so being a sort of European company, so we have looked at launch aid from various governments to feed into that. But we are now a global company, so we've extended the reach, looking at manufacturing sites now in China and also in America, in order to prove that we are, a real global engineering high-value company. We don't just do commercial, so we've got defence, so the A400M aircraft, the wings of which are built down in Filton in Bristol. And we've also looked beyond the sky into the stars, looking at the Mars rover and also HAPSF for the high-altitude pseudo-satellites, which Grazia mentioned this morning, has had the longest flight for a solar-powered aircraft. And we also got helicopter capability here in the UK and globally as well. So moving on to what are the commercial aircraft drivers for future sustainable aircraft. So the global market forecast we've looked at are looking at nearly 40,000 aircraft over the next sort of 20 to 30 years. That is a lot of aircraft, and if you look at the need of that, if we're looking at the duopoly of Airbus Boeing, that's about 80 aircraft that we have to produce every month from an Airbus perspective, which is massive rates, which is a rate challenge, is something we need to look at. And also, if you look at that amount of aircraft, it's also driving a need for about 500,000 new pilots over the next 20 years, which again is a massive ask, which is why autonomy and some of the things we've talked about this morning become all the more critical. And we haven't stood still. So again, you would have heard this morning about the movement. So we've looked at about an 80% reduction in CO2 and fuel burn since the start of the jet age, which is massive. But if you look at the petering off of the curve there, we're kind of reaching the limits of the technologies now that we know today with regard to the aircraft platforms that we're looking at. So we need to do something different. And then when you mirror that in with the challenges that are being put on us with regard to looking at our emissions reduction roadmap over the next 20 to 30 years, again, there are major challenges there that the platforms of today don't necessarily meet. So what are we looking at from an Airbus perspective? So again, I was hoping this was a picture you wouldn't have seen, but it did come up this morning. But we're looking at propulsion integration, so turbofans and turboprops, and also looking at hybrid distributed propulsion. Future power, like the eFan-X that was mentioned this morning. You did see a digital mock-up that showed there isn't much room inside the fuselage of the eFan-X, but that is because we've got batteries, we've got generators, and we've got technologies there that mean we're going to be adding weight to any new aircraft we're looking at from an electrical point of view. And if we're doing that, then obviously we need to see more advances in technology around advanced aerodynamics, around new manufacturing techniques, carbon nanotubes, new additive manufacturing technologies to optimize weight. And these are all things that Airbus are looking at in order to try and leverage the digital technologies of today in order to make sure we're producing better aircraft moving forward. Digital is something that is mentioned a lot, but it's how we can actually exploit those emerging digital technologies. From an industry perspective, certification and regulation is one of the key things that we need to drive, which sets us apart from the automotive and other industries. So it's not a burden because there's obviously no labour at 40,000 feet, but we need to ensure that we're following those processes. Also, disruptive markets. I mean, I was sat on the M42 this morning in the car park for about half an hour trying to get here. So, looking at eVTOL aircraft as a market is something that is needed with the growing population that, again, we talked about this morning. Full life cycle. So, we're looking at up to 85% of aircraft can actually be recycled. Carbon technologies is a bit more of a challenge, but we need to be more environmentally friendly for the full life cycle of the aircraft production and its life. And then operations as well. Again, you would have heard this morning around, do we look to fly in formation? Do we look to optimize the height of their aircraft, fly in order to minimize contrails? Noise is obviously a major contributor in airports. How do we look to minimise that with regard to the noise coming from the engines, but also the airframe, because that's a major contributor. So there's lots of challenges that we have moving forward, but so we'll look forward to hearing some of your questions in a bit. So I'll now pass you over to Martin.
Yep. Good afternoon. Just a little bit about Leonardo in the UK. We've been through several name changes over the last few years, so I thought it was probably important to reinforce who we are. Globally, Leonardo has about 46,000 employees across 170 sites globally. In the UK, we have three of the 5 major divisions of Leonardo that cover the work that we do, spanning the UK across 10 sites, about 7,000 people. That's us humble helicopter OEM people down in Yeovil, and then we have a multitude of sites that cover our electronics division capability and also cybersecurity. What we like about that is it actually positions us really quite nicely for future, what I like to call the aviation system, which is actually pinched from the Future Flight Challenge, but I really quite like that. I think it sums it up quite well. We have complete capability from right the way through the life cycle of design, development, experimentation to in-service support, customer training facilities. We also look at the exploitation of our technologies in multiple segments. I would argue that we are about, let's say, 45, 55 in terms of military versus civil within the helicopter industry. But what we're looking at and what we're seeing at the moment is the exploitation of civil technology into an ever-increasing military environment through parapublic and in some tier 2 military type operations. We pride ourselves on integration geographically. In helicopters, we are an integrated engineering organization with our Italian owners. We profit from that in lots of different ways. One is exploitation of technology. One is sharing and development and continuous evolution of our methodologies and our tools. And we also look at different work shares depending on different market segments. We have intrinsic relationships with the authorities, particularly with EASA, also with the CAA, but also our military authorities. So we are instrumental in helping to try and involve the regulatory framework going forward, and that's equally applicable to the way we want to move forward for new and emerging technologies. David mentioned the tilt rotor. We're very fond of the tilt rotor. It's a huge investment for our company at the moment, going through a first of type civil certification for tilt rotor, of course based on a pedigree of acceptance of tilt rotor technology from the now famous V22, which has accumulated almost 500,000, I think it's just exceeded 500,000 of in-service hours. A bit about the UK helicopters and where we see ourselves strategically positioned. We mentioned a lot this morning and also just now about UK capability. We have full OEM capability down in Yeovil. We have a sister capability in Italy. That's really important for us to underpin how we develop the economic input to the UK, how we develop IP, and how we actually conduct our business. We do that through 3 major pillars: sustaining and improving our products and services. So all of our investment looks to continually upgrade our current product portfolio, military and civil, and we do that through shared product roadmaps. Next generation capability, David mentioned, we have a lot of high-end work going on down in Yeovil, which is contributing to unmanned systems, contributing to tilt rotor technology, both in the near term and in the longer term through the Next Gen CTR program. And we're also looking at things like autonomy and how we implement that autonomous capability in step changes through to unmanned operations, but also our flight control systems. Strategic innovation plays an important part of our lives and our investment strategies. That is fully integrated with Italy in something we call the Product Technology and Innovation Plan. I'm not going to go around all the things, but there are some key drivers there for us, which would be things that are very novel to the VTOL segment in terms of enhanced dynamic systems, flight control, but also the way that we actually conduct VTOL operations. I wanted to finish on a couple of strap lines there, though. We are self-challenging. We have to look at the way that we invest to create future opportunities. We need to do that through increased collaboration. That's becoming even more apparent. The way that VTOL is going to be innovatively used in concepts of use and operation drives a strong, rigid requirements management culture into the company. Digitization, we've talked about that as well. That's disrupting the way that we do things. We look at that as opportunistic to how we can actually profit from that in the use of simulation and other tools to help start to reduce the complexities of flight test programs. Multiple technology exploitation paths speaks for itself, but that is important to us to define rigid and coherent business cases for us, and the business models themselves are also challenging. The biggest thing that we probably haven't talked about too much today in either this morning's session is the people. The thing for us, the big strapline for us is how do we adapt our skills to sustain our current capabilities, but also prepare ourselves for the future. And we're doing that by lots of different ways, but that's recruitment campaigns, which are always quite difficult in our sector anyway, and not many people want to come down to Somerset and Yeovil, for example. They prefer the big cities. So we've got to look at how we do a balance of recruitment, young talent, so apprenticeships and graduation programs are really key to us. Down in Leonardo, but also how we adapt and train our existing skills for the future. Thank you very much. I'll hand you over to Michael.
Thank you.
Yeah, don't fall off the stage.
Yes.
There's not much room back here.
Quite a drop there.
Yeah.
We have the balancing act of do we walk down and suddenly look short for a second or crash into each other. Just a bit of a background introduction on vertical aerospace. So actually really pleased to see several pictures of our aircraft earlier today. We're booming onto the aerospace scene in, for me, what is really the most exciting time that aerospace has seen since the 1960s. And I passionately believe, collaboration was just mentioned, that it's going to be that combination of really edgy, fast, agile startups like Vertical, partnering with some of the big capable players and across different aerospace industries, that's really going to lead the level of disruption that this industry needs. We were founded in 2016. In fact, 6 engineers over a period of 1 year designed and built our first prototype. So I think Paul Stein this morning talked about 170 companies in this space. Only 11 have actually flown a full-scale prototype. We're one of less than 5 that have flown 2 different full-scale prototypes. And those 6 engineers in 1 year designed, tested, built, and flew a prototype, including all the inertial representative drones to tune the control systems, etc. Amazing achievement, but frankly that was just about getting the company off its feet and getting it started. Since then, we've developed and built and flown a much more complicated vehicle, and I'm just going to show you a video of that, short video of that, and then I'll talk a bit more about the Seraph and where the company is going. If you can play the video. So Serif was, for us, very much a technology stepping stone. One of the comments on the earlier slide was we're now a team of 70, so we've grown from scratch to 70 in 3 years. We'll reach 100 by February next year. And I think there's a couple of distinguishing features about us against a number of the other startup companies. We've got 50 people in Bristol, in the heart of the aerospace cluster in the UK, and we've just bought the F1 consultancy team, Mike Gascoigne's consultancy group, so bringing in 20 world-class F1 experts based in Oxfordshire. So from a talent perspective, that enables us to now fish in 2 really key and distinct recruitment pools and bring in diversity of thought and approach. So with the F1 approach, it's very much a learn very rapidly, lots of experimentation, clearly hitting deadlines. You know, the first race of the season, if you're not ready, it's going to happen anyway. And for us to be competitive in this world, having that kind of experimental, agile, fast mindset, combined with some of the F1 technologies around lightweight composite structures, systems integration, thermal management, aerodynamics, the whole F1 ecosystem that enables that pace and agility in different technologies is key. Combining that with real aerospace pedigree. So we've got, for example, our head of airworthiness was head of airworthiness for Airbus. I've spent 22 years in Rolls-Royce. We've got deep aerospace expertise. Serif really for us was that kind of initial stepping stone therefore. This is not the vehicle we're going to certify. We're already designing a much more capable and complicated winged vehicle. Our intent is really over the next 12 months to de-risk that winged vehicle and get the company ready to take a cert program. So we're targeting certification late 2023, early 2024. Really rapid timescales. The only way we're going to do that is by leveraging both our own pace and agility, but also by working with some critical partners. So here, for example, we've demonstrated significant increase in things like redundancy. So we flew this vehicle, we did a motor out demonstration, we safely landed the vehicle. We're the first company in the world to have partnered with Honeywell. So Honeywell's bringing F-35 technologies for the flight control systems. I was out there last week. I flew one of their helicopter demonstrators. First time I've ever flown a helicopter. I have newfound respect for people who fly helicopters. One of my team made the boss look good. He couldn't even get off the ground. I got off the ground. I didn't quite land it. I then actually flew some of the latest technologies Honeywell have got that we'll bring to bear on our next product with the unified flight control system. And suddenly the pilot is no longer flying the aircraft. He's telling the aircraft where to go. And that was very, very straightforward for someone who is not a pilot. Bringing in that kind of operational capability with really state-of-the-art vehicles, I think has got huge potential to disrupt this market. Thank you.
Right, so now we get on to the hopefully interesting bit. I should have said earlier, as you've seen in the agenda, the plenary panel sessions are saved until the end of the day. So if you could save all your really hard questions until then, I think the panel would appreciate it. So let's see if I've gone too far. Can we go to the next one? Just get the panel back up again. Goes at the back. Go to the next slide. So we just got the panel back up. Or not. This doesn't seem to be working. Yeah, I tried that. There we go. Right. So, looking at the list of questions then, the first question that's come up, what are the biggest challenges to making aircraft sustainable? It's a tough question, but that's what we're here to ask. So, Dave, given that that's related to the commercial aircraft, I think the most from this morning, can I come to you first?
Yeah, I think it's twofold really. So, I mean, we talked this morning around, short range, looking at electric propulsion. But, that is for short-range aircraft. If we're looking at sort of long-range transatlantic flights, the power density of batteries isn't necessarily going to afford that sort of technology, so we need to look at something different. And then sustainable aviation is what's needed, and sustainable fuels. Probably the biggest concern for me is around certification legislation and how we actually look to certify those new technologies as we move forward.
Okay. Martin, what about you? What do you think?
Just two aspects I would add to what Dave said. One is design to cost. I think there's a trade-off between how we as engineers could actually over-engineer things. We can overcomplicate things, but actually there's a balance of performance and functionality versus how much it actually costs to reproduce that in a decent levels of volume. And then the other one is how you actually maintain it and how you provide that service. So I think where we're moving now is not so much to just the vehicle, it's about providing a service.
Michael, you're coming at this from a slightly different perspective.
I guess a couple of perspectives. For me, firstly, there is no single silver bullet that solves this problem, and actually it's going to need sustainable fuels, electrification, all the kind of improvements that were touched on earlier. Clearly, one of the key factors about Vertical is our founder, Stephen Fitzpatrick, who founded OVO Energy, has been a passionate supporter of sustainability, carbon taxing, and so on. And we've really set up Vertical, yes, to initially focus on eVTOLs, but actually to build, hopefully in the long term, a world-class aviation company that can build up from that. We strongly believe that electrification will play a part in that. It's certainly not the silver bullet that fixes it all. But eVTOLs represent a really golden opportunity to bring those technologies in at scale, de-risk them, pave the way in terms of regulations, and ensure that we can deliver the safety that the aviation industry comes to expect. So I think starting with those smaller vehicles where the powers and the ranges and so on are more manageable, they're still pretty difficult. We're doing this because it's hard, not because it's easy, but it's just on that cusp of being viable. For me, starts to set the groundwork from which we can expand into the wider aviation sphere.
Thanks. I guess I would just add my own thoughts to that, which are, I think people are too readily hung up on the operational aspects of sustainability. So what's the fuel burn, things like that. There are many other things around manufacture, around recyclability that are easily overlooked and actually have potential cost benefits and things like that as well. So buy to fly ratio and all that kind of thing. People don't see that as the sexy stuff, but actually it's every bit as important to making vehicles more sustainable in an overall sense.
I guess just one addition as well. I mean, Martin mentioned skills earlier. You look in all these disruptive technologies that are coming in, and it's how we can exploit those technologies with the skill sets that are needed. So it's not just the new starts coming in, it's also the current workforce we have, how we upskill those with AI, data analytics, etc., in order to leverage those new skills to give business benefit.
Okay. I'm just going to, given that you brought something up, Dave, I'm just going to jump to the next question, which is the certification challenges associated with electrification of aviation. Michael, I'm going to come to you first, because actually your route to market for vertical aerospace depends on finding a way to do that.
So I guess for us, we're one of probably only 2 or 3 companies, really, if I'm honest, that are seen as credible with EASA in terms of the startups in this space at the moment. EASA, most of you probably know, has published something called SC VTOL, or Special Condition VTOL, which sets out an overarching framework for how to certify these vehicles. Sets rightly some really demanding challenges. So it actually puts the same level of safety requirements on the enhanced category for commercial operations and operations over urban areas. That is the same safety standards that we expect on civil large engines. And given we hope that lots of these vehicles are going to be flying, that is absolutely the right benchmark to set. If you step below that, whilst that might set an overall target, it doesn't set the acceptable means of compliance. So we're working with the authorities to define those with a number of industry bodies. So Vertical, in fact, leads the battery working group under EuroCai, and we're present on the other committees. And really they are laying out the foundation. So for us, there are a number of areas of SC VTOL that are already covered by existing Part 23 and Part 27 regulations. There are clearly some gaps because these aircraft are novel. And actually I'm seeing generally a convergence in industry and regulatory bodies over many of those regulations. We're not there yet, but our belief is we will be there in the timescales that we need to certify. I think perhaps the one other thing that for me still needs work is harmonisation between EASA and FAA. We're seeing that happen in certain areas, but not uniformly. And so one of the key things for me is to make sure that they don't step out of alignment. In our case, clearly, we will certify through EASA first, but we actually want a level playing field. We don't want the EASA regulations to be more or less burdensome than the FAA, and we want to ultimately cross-pollinate certification. So I think there is still some way to go in terms of achieving that harmonisation. Great.
Dave, Martin, anything to add?
Just about partnerships, really, because, I mean, what we're learning on the 609, which is, as we said, the first of type for a civil tilt rotor, is that you have to work really, really closely with the authorities. We've gone into a relationship with the FAA, bringing EASA along with us, which actually allows us to help each other establish what the policies are, establish what the rule sets are for unique non-conventional VTOL configurations. That's probably something that Mike was working on. The other aspect for me is environmental aspect. So with electrification, clearly the E-cubed regulations, which are qualifying of components, failure of equipment, but also operation in things like lightning environments, are going to be critical going forward.
Maybe it's not certification based, but if you look at eVTOL aircraft, in order for them to be viable, you want to carry as many passengers as you can to reduce your cost per seat ratios. So in order to do that, autonomy is going to be key. If you need autonomy, you need artificial intelligence. And I think we need to first explain what artificial intelligence actually is. Then we need to be able to get the trust in the technology and then be able to certify it. So I think there's a whole route around hearts and minds about the public that was mentioned this morning. That's obviously key as well to making sure this could work.
Great. Again, just to add my final thoughts on that, I think there's actually a UK challenge around certification of these vehicles, particularly in the small space. If you look at SCE VTOL, as I read it at least, it was fairly evidently written with specific vehicle concepts in mind, none of which come from the UK. But we've got to recognise that it's a big burden on an individual UK company to be able to have that level of engagement with EASA, with EuroK, with all of these different groups that are coming up with standards. So I think actually the challenge for the UK is to find a way to pool our resources to have a collaborative approach to going into those forums with a UK hat on. I know that's a big challenge, but that's one, we're here to address big challenges. And so that's the challenge I'm going to throw out today to those of you in this room. How do we come up with a way of doing that and doing it better?
I think if I can add, there's one other thing I'd point out is how do we find novel ways of basically demonstrating the intent of the regulations. So as an example, automotive clearly has certain levels of qualification on a lot of the electrical components that might have some degree of read across. So when we now start looking at an aerospace regulation, clearly we'll have additional things on top, but do we have to go and repeat everything that automotive has done and start from scratch, or actually can we rely on some basis of existing demonstration elsewhere?
Okay. Right, well, next question. So slightly different tack. Will there be a convergence in eVTOL concepts, and is it a winner-takes-all market? I'm going to add regional into that as well, because I think this is, both are relatively new markets if you're looking at them from an electrification perspective. Dave, given Airbus is involved in all of these markets, what do you think about that?
I think it's different requirements, isn't it? So we talk about transatlantic flight needing sustainable fuels, and we have the duopoly at the moment, but there are emerging competitors in India, China, and Russia that could potentially disrupt the current way that we're working. I think if you look at the disruptive side of it in the UAM, I mean, I mentioned earlier this morning that in Farnborough there are 200 companies launched products, and that is massively competitive. But it's say getting over the certification needs, getting first to market will obviously be a key driver in that. But Airbus has the City Airbus and the Valhalla over in Silicon Valley that we're flying. Boeing have similar. There's so many products and good products that are being driven. Battery technology obviously needs to evolve in order to improve the power to weight ratios. But it's getting there, and I think as you say, if you can get certified by 2023. I think Airbus is looking at sort of 2026 before getting a product to market. Then there will be real competitiveness there, and we should see some really good products.
Martin?
I think the opportunity is huge in the sense that what we're studying at the moment in Leonardo is the requirement set. Short, medium, and long range capability. How fast do you want to get there? What's the real productivity of the service that you want to provide? If you just look at geography, it will tell you that every country is probably slightly different. So your choice in which segment you go for is absolutely critical. Technology is obviously critical in terms of making that viable, but equally so is the scalability of that technology for the particular segments you want.
Okay, and last but not least, the new kids on the block.
So I think already has been alluded to, there's going to be a significant fallout from the 170 odd companies. Only 11 have flown the numbers that are actually capable of certifying a vehicle and understand what that takes, both from an engineering, financial, etc. point of view, is going to result in a significant fallout. My personal view is there are a vast number of different use cases, both globally and different markets. So whether that's intercity, intracity, sightseeing, cargo, freight, high net worth individuals, medivac, I could go on, construction, ship to shore. So actually, firstly, there are a wide range of different markets. I think there will be a convergence, but certainly not to a single type of vehicle and not to a winner-takes-all market. There are different trades in this space. One of the challenges actually is balancing noise versus hover efficiency versus cruise performance versus payload versus cost. Do you have a swappable battery system? Do you have a more efficient vehicle that can fly faster? Very much our philosophy is to come up with an architecture that we can future-proof, that we can upgrade, and that we can tailor to some varying different market positions, but we have kind of no delusions over we're going to have the winner-takes-all. So I think there will be a degree of convergence, but we won't see a single concept.
Yeah, I mean, I think you could look at it in a similar way to automotive. Yeah. So there are different, it's slightly different, but different brands within automotive have looked at specifics around different customer requirements. Some people want, quality and prestige. Other people just want the ability to get from A to B. So I think there will be space for a range depending on different requirements. Moving on to a different area again, which non-aviation sector do you think could best help the design of future vehicles? We've had a couple mentioned already in the intro presentations. Martin, I'm going to come to you first on this one.
Ooh, thank you. It's a huge question, but I think we did touch on it this morning. I think the power source is absolutely fundamental. So I think the fuel side of it, the way that fuel might go, battery density, we heard is an evolution. It's going to take quite some time to get us the paybacks that we're used to in terms of profitability. I also think one of the things from our, let me say, almost blinkered aerospace company perspective that can help us is system integration. So I think it's that system of systems type capability where I'll come back to what I said in my introduction, is that I think that non-aerospace industries which maybe look at operating a wider network of transportation in complex systems will be something that can really benefit us and shape the way that we actually do our future business in this sector.
Michael?
So the obvious one for us is F1, but actually I've always been a passionate believer in diverse teams. So in Vertical, we very deliberately recruited from not just F1, automotive companies like Dyson, other industries. So F1, actually, we're having a really interesting time as a company. So 20 of our 70 employees are F1 technical specialists. They have very much a kind of rapid iterating, prototyping, kind of evolving approach to life. Aerospace, of course, has got the deep requirements, slow down the classic V. So in the time the aerospace guys have worked out what the question is, the F1 guys have probably done 5 designs, thrown the first 4 in the bin, but actually by the time they've got to the 5th design, they've learned a hell of a lot in the process. There are times when that is absolutely appropriate as an approach, and there are times when it is absolutely not appropriate. So I think there's a really interesting approach from that. The guy we've got who's our battery specialist, who's leading the Eurokai battery working group, is ex-Jaguar Land Rover. He led the Jaguar I-Pace battery design. But then I think, if you stand back, well, we're trying to build an aerospace company that does things differently. How do we leverage digital? How do we build system test benches that can run 10,000 simulations a week? That requires different levels of agility and AI and approaches. Medical industry's got fantastic capabilities in inspection. So I think there's a whole opportunity for spaces outside of aerospace. And whether you're in small companies or big companies, we tend as an industry to be quite insular in our approach. There's a whole world of opportunities out there, and often it's just about finding the problem that someone else's technology can solve for you.
Dave?
Yeah, I mean, it's a good point mentioning the SMEs, because I think we recognise that the innovations aren't going to come from the Airbuses or the Boeings. They're going to come from the teenagers coming out of university or the SMEs. So it's how we drive those collaborations within the UK in order to exploit those new innovations. In the Brunel Challenge was mentioned this morning, and that could be critical in how we link the primes with regard to the brain power, the SMEs with regard to their innovations, and the ATI and local government around how we fund those grand challenges in order to really be able to drive the UK economy around aerospace and cross-sectorial industry.
Great. Okay, well, there's actually a related question slightly further down in the list that I'm going to jump to, because I think actually that's a really good point to pull it out. And it was around, how do you think new entrants and startups can work with established aerospace companies, as the first part of the question. And the second part is, do you think there's an ATI type program or something that we could do to get people working on together to galvanise that? Michael, do you want to come to you first?
So I mentioned the fact we've signed up Honeywell. So I've always held the view that building a startup that gets DOA, POA, so design and production organisation approval, develops a vehicle, takes it through to production, builds a supply chain, is one hell of a challenge. And I like challenges, but that's one hell of a challenge. And the only way we've got any chance for me of succeeding is by partnering. So Honeywell is the first publicly announced partner we've had with a big aerospace company developing our flight control systems. We're partnering with other companies for things like battery management systems, powertrain, a whole range of different aspects of the aircraft. Atkins helping us on the aircraft sort of health assessment. So partnerships for me are really critical. I think, clearly we'll build those out over time. One of the things we found interesting with Honeywell is Honeywell really believes in this space. And they've taken a view that in order to be successful in this space, they're going to have to operate differently. So they've set up much more of a ring-fence team that gives us fantastic support and really agile support. And it's everything from the way they work with our engineers to the way they do contracting. Normally, if you want to sign a fly-by-wire control system contract with a big aerospace company, the numbers are simply eye-watering, not affordable for a startup, and you'd end up with a lever arch file contract. We managed to negotiate it in a few days. We got sign-off from Honeywell within less than 24 hours, and the contract is on a few pieces of A4 paper. So for me, that's a really good example of the successful big companies that want to play in this space are those that can adapt. And I think the successful startups are going to be the ones that actually know how to work with big companies. And actually, for us, it's about being an intelligent customer and working together. So Honeywell can't develop the whole flight control system for our aircraft on their own. They won't certify it on our vehicle. We will have to certify it. So for us, it's how do we recruit the right skills, and how do we have that collaborative relationship that just operates on a different pace and a different cadence, can leverage all the capabilities that big aerospace companies can bring, and hopefully bring some of the agility and the pace and the mindset that we bring to the table.
And is there anything the ATI can do specifically?
Sorry, I didn't answer the second part of the question. So I think there's a really interesting space there. I mean, so we've clearly, through our company, got some really good contacts in industry. We're aiming to build an aerospace company that is a really exciting route to market for a UK ecosystem. Many of the decisions we need to make about supply chain, there's a huge technology landscape that we have to overcome to make these vehicles competitive, are not in place yet. So Dave, as you know, we had you in a couple of weeks ago. For us, there's a really exciting opportunity to create a portfolio approach that actually builds out that R&T strand, brings our kind of route to market, combined with successful startups, big companies that will have fantastic technologies. Ultimately, we want to be competitive. I'm not choosy about how we do that, so if the ATI can help us on that journey, then brilliant.
Okay. Martin?
Can
you remember what the question is?
Yeah, I can. Not much to add, because I think the answer was absolutely spot on, but it's just the inverse for us. The thing for us is we get trapped sometimes in policy, in processes, in some of the cultural aspects that we have within our companies, our big companies, that actually say, we've always done it like that, so we must continue to do it like that. I don't necessarily agree with that. I think what we've got to do is challenge ourselves, which is why I said to be self-challenging. We have to be open to embrace startup companies like Vertical Aerospace, to permit them to be agile, to permit them to do the stuff that they like, but actually support them with the knowledge and experience of what we've built our heritage upon, because we're not there where we are by accident. We're not there from 3 years, we're there from 100 years of trial and error, and we've done a lot of work to get where we are. The point is there's a compromise in there somewhere that actually says that we can help companies like yourselves and maybe not make serious mistakes that we've also done in the past. We can help them share that knowledge, but equally there's a transfer of knowledge and capability that might actually say that we've got to do things slightly untraditionally that we're always used to. Is like, give it all to us, it's transactional based, you can keep your IP, but give us the interface drawings and we'll do everything else. I think those dynamics have got to change if we want to realise some of the stuff that you're doing.
Absolutely.
Dave?
Looking good for 100 years.
Yeah, thank you.
I mean, collaboration is key, isn't it? And I think, there are good pockets of where we do this well. We've got the Global Technology Centre being built from GKN down in Bristol. We've got the Airbus Wing Integration Centre. We've got the NCC. We've got the catapults. There are areas of collaboration that we can really leverage, how we can attract the SMEs into them more, because one of the key things around IP, and they come in with their ideas, but we need to ensure that we just don't suck it up into the big companies and they lose all their IP and their capabilities. We need to ensure that we're protecting them, that those ideas give benefit for the UK and they stay within the UK.
Just to add one other example, we are going through a certification process at the moment for one of our smaller UAVs. That is a completely self-contained almost group, an integrated design or development group within our company, which is left unencumbered by the rest of the group. It still follows some of the constraints of policy and procedure, but not to the same degree, and we enable them and provide the support to them to expedite the design and development process. So we are looking at ways that we're doing that within the companies, but we must do.
Great. Okay, and likewise, I think there's some really interesting thoughts there. But again, I'll throw out a challenge to the room. If you've got ideas in your companies for things that you want to do, whether that be projects with the ATI, projects with other companies, projects around infrastructure, if there's a test facility that you need in order to get to a product and you can't afford it, then come and talk to us, because it's likely that there'll be other companies that either have that capability already and we can broker those discussions, or we can look at implementing a UK centre of excellence or something along those lines. These are the kind of ideas that we're looking for from industry. We have some of our own, but actually, again, it's ultimately about what you guys need. That's what we're here for. With one eye on the time, we've only got about 5 minutes left, so I'm going to ask a massive question. What do you think the key issues are to get to the implementation of full autonomy? This says in passenger UAVs, but in reality, I'm going to widen the question out because it applies to everything equally. If you can do it in a 5-person vehicle, you can do it in a 200-person A350. Actually, for me, the challenge isn't that different. So, Michael, what about that?
So we see it as a series of steps. So I think the first thing is, how do we make the vehicle as easy to fly, aviate, navigate, etc., are the kind of premises of being a pilot. So step one is have a really simple flight control system that takes all of the complexities out of the vehicle. Have a fantastic avionics suite that automates as many of the pre-flight checks, the maintenance activities and so on, and starts de-skilling the level of skill required in the pilot. For urban air mobility to take off, if everyone has to be trained to the level of a highly skilled helicopter pilot, it's going to self-restrict very, very quickly. I think there's some really exciting technologies coming through, things like really lightweight compact radar systems that can be used for detect and avoid. Actually, in some ways, the airspace environment is far simpler than autonomous cars. You don't tend to have kids running out in front of cars with prams. Some of the ethical issues that you have to overcome on ground-based vehicles are easier in the sky. The implications of it going wrong can be more severe. Even if we're talking about an eVTOL, it's a multi-ton vehicle flying over a city. If that goes wrong, then we all know the implications are going to be more severe. So I think for us, absolutely the first vehicles we'll certify will have a skilled pilot. We'll want to make their workload as simple as possible. gradually increasingly automate key parts of the flight envelope, key parts of the decision making, prove out that technology, build up the hours, build up the customer confidence. So for me, never mind the regulators, actually customer perception and customer confidence is going to be a key driver. Acceptance of that probably won't be the same in different parts of the world or even within different generations. If you ask my 4-year-old daughter, she has probably quite a different perspective on being willing to get into one of these vehicles without a pilot than someone my age or older. So I think it's gradually increasing that level of automation, eventually going towards remote control and eventually final autonomy. But it's going to take quite a while. And I think it'll be an ecosystem of players that bring that technology. It's not just going to be aerospace primes, tier ones, etc., that know how to do this. They're going to have to leverage capabilities from other sectors.
Martin, you've got a slightly different perspective from the helicopters and things like that. What do you think?
I mean, I'm glad he took up the 5 minutes. The thing for me is safety. Safety. The issue for me, I'm not so worried about normal operation. I think what we do, it's how do you manage failure? What happens when you have subsystem failure on your aircraft? What happens when you're in an emergency condition? How do you deal with that? And the issue for that is convincing the public that you've done a good job. Because what happens when we're in an urban air mobility environment and we have an accident? That's what will kill it if we don't do the job properly now. Do we have the technology to do the job properly? Yes, absolutely. But we've got to come up with some policy and some rule and regulation, as Michael was alluded to earlier on, that allows us to deal with that in an appropriate manner. I also think, and I'm not sure whether or not I'm right or not, that there could be a different perception with the different generations that are coming up through. I now go to an airport terminal like everybody in this room does, don't think anything at all about getting on a train between two terminals, which is fully automated. Yes, it's easy, it's on a track, I'm not going to fall off and all that sort of stuff, but how long will that take to get it into an airborne system is interesting. Perhaps some of us in this room might not get on one, but I'm sure maybe our kids or our grandkids might do. And that's going to take a serious amount of time and effort for us to do that in a very regulated way.
Dave, what about you? Do you see single pilot as a stepping stone to autonomy?
Yeah, definitely, and I think that's one thing that we're really starting to try and push. I mentioned earlier with the global market forecast of 40,000 aircraft drives 500,000 new pilots required over the next 30 years, which is massive, and that's recruiting sort of 7 a day, which just isn't feasible. So something has to change. But again, I think you're right. I think it comes down to hearts and minds and how we can really drive that. But I think the government side of it is going to be key as well, looking at the corridors, looking at the traffic management systems, looking at the system of systems, and how we define that complete ecosystem, if you like, of the technology to really start driving it forward.
Great. Yeah, I think it's a really interesting challenge.
Yeah, it is.
I agree with most of the points that have been made, and I think but we also, back to one of the earlier questions, have to look at where we can learn from other industries. Arguably, flying a predetermined flight path is easier than driving an autonomous car through a city because you've got completely unpredictable hazards in a way that you don't necessarily have in the airspace. And I think it will be fascinating to see how we can adapt to that. And the other thing is, of course, people often overlook that humans actually overcome small issues all the time. It's a bit like restarting your computer, but no one records them. If the pilots know they have to toggle the switch a couple of times to get a certain system to work or, reset it, that doesn't really get recorded. But if the pilot's not there, you've got to come up with a way where the system doesn't have that infinite loop.
Exactly.
And actually, then it becomes a challenge of validation and how you validate those edge cases.
Yeah, not what he does normally.
So I just give my iPhone to my 8-year-old daughter. She sorted it out for me.
Okay, well, we're going to have to draw it to a close there. Thank you very much for all your questions. I hope you found it interesting. After this session, it's the structures panel in this room and the systems panel in Vox 2. So all that remains is for me to say thank you very much to all the panellists. That's been really interesting. I'm Dave Debney from the ATI. Thank you for listening.
Thank you.